All right, so let's get started. Um, Welcome, everybody. I know it's 9 a.m. on a Saturday morning, but this is the Pocket Network V1 prototype deep dive. And if we want to ship on time, we really got to start prototyping earlier rather than later. So they should have been at 6 a.m. if anything. But I'm gonna dive into it in a moment. All right. So I'm going to skip the introductions and just jump straight into it because I know why everybody's here. You want to know when are we going to launch the V1 testnet? You want to know how can you run your own V1 node? You want to know about the numbers, the benchmarks, all associated with V1. And of course, everybody cares about rewards, so you want to know what's going to happen with your earnings when V1 comes out. These are all great challenging questions, and I'm going to tackle some of them and answer a few of them. But in reality, what I want to do today is give everybody an insight into some of the discussions that we're having day to day, the problems that we're solving day to day, and then you can really get an insight into the work we're doing and then maybe answer those questions for yourself. So my name is Daniel Olshansky. I work on R&D for the V1 protocol. I've been here for about 6 months, and it's been a rocket ship on a roller coaster every single day. And there's just so much work going on, and I'm really excited to share it all with you today. So what are we actually going to talk about? First, I'm going to set some framing and explain why are we actually building V1. Then I'm going to go into a high-level architecture, so you understand how we're actually building it and why we're building it that way. Then I'm going to give you an R&D update, but I figured that since we're here in the DR, it's a DNR update. We develop first and then do some research. And then I'm going to tell you about the tooling we're actually using to do all of this development. And at the very end, of course, what everybody wants to know is what's next and what are we actually building. But just as a disclaimer, everything I say here today is not immutable. The specs are still live. Everything is still changing. The core team members, everybody here can still contribute to the changes. So some things the DAO cannot hold me liable against anything I say. All right. So why build V1? In order to really understand why we're building V1, I think it's important to understand why we're not building V1. What are we not optimizing for? So we are not a blockchain that's optimizing for general purpose compute or general purpose storage. And like a lot of other blockchains and projects like to tout out there is the shortest block times or the highest TPS. That's not what we need to optimize for, right? In other words, we don't need to do all the things as fast as possible. And when I realized that, I kind of took a step back and I wanted to start thinking, so why is everybody else optimizing for the shortest block times and the highest TPS? Like, what is the framing that actually leads that thinking? And there's a few common trilemmas in the crypto industry. One is by Vitalik, the scalability trilemma, where we optimize for security, we optimize for decentralization, and we optimize for scalability. Now, with the work of everybody here and the protocol team, the growth team, the community, we've done a pretty good job at solving all of these problems. So it almost felt like we're kind of cheating. And so I decided to think, so what is actually the problem that we're trying to solve? So another common trilemma is Vlad Zamfir's triangle of compromises. And here, it was actually much easier to frame the problem. We have a pretty large number of nodes by industry standards. We have a pretty low overhead, but we have a high latency, so our block times are shorter than most. But that actually doesn't matter, and I'm kind of going to jump into that more later in the presentation. But these two trilemmas actually set the framing for everything that we're going to need to do. So what are we actually building for, and what are we actually trying to optimize for? Well, we're building an application-specific blockchain to enable decentralized and universal Web3 access. And most of you may have heard of the Cosmos SDK, and they also provide an SDK to build application-specific blockchains. And they got us to where we are here today. However, the next step of all this is building an application-specific blockchain with an application-specific code base. And that's how we're going to reduce code and architecture complexity. That's how we're going to optimize for our utility. So a lot of decentralization, low relay latency, and of course, we got to thank our node runners. Everybody wants to maximize node runner ROI. But more importantly, and the thing that's kind of, I think, most important to me, is developer productivity. And when I say developer productivity, I don't just mean dApp developers, because that is kind of the original vision. But I also mean protocol developers. What we need to do is anybody should be able to contribute to the protocol, make modifications, experimentations as easily as possible. That's where we're building everything from the ground up. And of course, everyone has their own little passion side project. For me, it's interoperability. So no promises here, and if anyone from my team who's here might kind of be looking at this and saying, Daniel, what are you saying? But we'll see where that goes. So, but why are we doing this right now? Well, we've hit a few scalability issues. So Tendermint, for example, had a 10,000 validator limit, and right now we're at 1,000 validators. Up on the screen, I also have a screenshot from one of the proposals in order to reduce the memory footprint of our nodes, because this is also turning into a scalability issue. So now that we are all, but in addition to that, now that we know what we're building and that we're working around some of these scalability issues, now is the real time to build V1 from the ground up, optimized for everything that Pocket Network can really bring to the world. But I introduced a couple trilemmas. And in order to really frame the thinking for everything the protocol team is going to do and everything we're going to do together, what do you guys think is really the thing that we need next? I know no one said anything, but I can tell that at least 2/3 plus one of you are thinking it. We need a third trilemma. So here I introduce the RPC trilemma. And this is the most overlooked problem in the industry today. RPCs need to be reliable, performant, and cheap. When I say reliable, we get all of our typical blockchain stuff. It's decentralized, it's trustless, it's incentivized, it's censorship resistant. This is what makes a blockchain a blockchain. And this is actually where most centralized service providers today are missing out on. Now, performant, obviously we want to be as fast as possible. You want your latency to be as small as possible. And of course, we want it to be cheap. And when we say cheap, it has to be cheap for developers to use. It has to be cheap for node owners to run. And we also want it to be cheap for the network. So we don't want to overload the network with too much congestion. So the RPC trilemma is why we're all here today. All right, so what does the V1 architecture actually look like? And we have the RPC trilemma, but when I first started working at Pocket, I actually spoke to somebody who used to lead the Tendermint team, the Tendermint development team, and I asked him, can you give me like the best lessons of developing a blockchain? And you'd think that I get some very crazy insight about with some really cool algorithms, but it's all very simple. You know, we want to make sure we use standard serialization protocols. We want to make sure we keep things as simple as possible. We want to make sure we don't roll our own crypto. These are all pretty basic lessons. But even more importantly, and something that surprised me, is formal verification is always really cool and sexy and exciting, and everyone kind of tweets about it. But in reality, when it comes to implementing a blockchain and releasing a blockchain, QA and tooling and infrastructure is really what helps you launch it in a secure manner. And here being an Infracon, I think that rhymes quite well. Now, as we're actually implementing it, one of the things that we always keep in mind is to keep things as simple as possible. So we keep our architectural complexity low, but not too simple. And one of our team members constantly asks, what is quality engineering? He asked me this during my interview. He reminds me of this every single day. And I will say, every single day when I wake up and I start writing code, I always think, what is quality engineering? And clearly right now, he knows what is quality sleeping. All right. But like everything in life, it's a balance, and we're trying to find that balance. We need to move fast, but not too fast. We need to break things, but we can't break everything. So it's a constant balance that we're all trying to find together. But jumping into the actual architecture, we researched a lot of different blockchains and tried to understand what does their architecture look like before we started implementing ours. And one I picked in particular is Flow. The only reason I picked this one in our research is because they're a smart contract L1 platform that uses a similar consensus algorithm to us. But the thing that's interesting is, look at all of these actors that they have, protocol level actors. They have collectors, they have validators, they have verifiers, and they have executors. All of these protocol level actors are necessary in order to efficiently execute smart contracts at the L1 layer. Pocket is completely different. Our actors are actually split into applications, which need to stake in order to use the blockchain, in order to use the utility of the blockchain, servicers, which need to stake in order to provide that utility, fishermen that need to stake in order to overlook the servicers and make sure that the utility is secure and correct. And of course, we need validators to ensure the integrity of the blockchain. So for us, the validators perform the entirety of the work that all of these other actors on Flow perform. And this is different, but also an opportunity because it lets us keep things really, really simple at the blockchain level and optimize for what Pocket is actually good for, optimize for Pocket's utility. So what I want to say here is Pocket's utility, the blockchain isn't the end goal, but the blockchain itself is what enables the end goal. And that's what helps us keep architectural complexity low and optimize for what we need to. Okay, so that's kind of what the protocol level actors look like, but then what does the architecture look like? And I've got a couple diagrams here. So first we have a block level diagram, and this just kind of summarizes what all the modules look like. So we got the utility module that kind of crosses the boundary of the servicers, the applications, the fishermen. We got the consensus module, we got the P2P module, and then we got the persistence module. So it's all pretty simple, 4 big modules, but then what does it look like when we jump into the implementation and the system diagram? And this is the beauty. It looks very, very similar when we actually start implementing it. We got the persistence module talking to the database. We got the P2P module talking to the external world. And then we got the consensus module and the utility module performing the actual functionality of the Pocket Network node. The one thing that's new here is the application-specific bus. So the beauty here is we have this bus that enables all of the inter-module communication between all of our modules. And in the next slide, you'll see that this is actually what's enabling our very rapid development and prototype, and is going to enable the rest of the community to contribute as well. So here's our system diagram, and here's some Go code for all of you Gophers out there. So we have a general purpose module interface with your typical start and stop and access to the bus. Now, the bus was designed in such a way that it's split into 2 components. We have the asynchronous piece, which kind of mimics typical system design event bus architecture. And then we have the synchronous piece, which you can think of more of like dependency injection. So this gives you synchronous access to any module from any other module. And now, like all software engineers out there, With just one line of code, you can get access to any module from any other module. You saw it here first, folks. But seriously, from the utility module, you get access to the bus, you get access to the persistence module, and you can start making calls to the interface that it exposes. The other beauty of this is really letting us test and implement and mock and iterate quickly. So it's cut off a little bit here, but when we're running the node, if I want to test consensus in isolation from anything else, all I need to do is mock the utility module, replace the utility module with a mocked version of it, and that lets us test consensus, try to break it, and see kind of what happens. The other great thing about this is that literally this past week, this is a screenshot from GitHub in a PR that hasn't been submitted yet. One of our other engineers is adding a telemetry module. So again, with one line, you get the bus, you get the telemetry module, and then you start incrementing counters. What I think this is going to enable is as the community grows and as others want to contribute with their own modules, you can literally add your module, implement it how you wish, and then you can start customizing it. So you can imagine we can have a report card module if you want to customize how rewards are provided. We can have some sort of challenge validation module if you want to customize how the client can challenge the servicers. This is really going to enable all of that. All right, so that's kind of the high-level architecture that's driving out of all of this. And then I want to share a little bit about some of our R&D updates. And I know I made the amazing joke of being in the DR and doing D&R rather than R&D, but when I started thinking about it, I actually thought that there is some truth to it, because rather than kind of how you see other blockchains doing a ton of research and a ton of formalification and then diving into development, our research is very development-driven. So we do some research, we do development. We do some research, we do development. And this is a never-ending cycle. So I'm going to call it development-driven research. Now, I won't be able to jump into all of the specs and provide all of the details about everything, but I do need to talk about the utility module. This is really the reason why all of us want to have Pocket in our pockets. And some common questions I get all the time, and I'm not going to answer all of them because it can open up a whole can of worms, is who's watching the watchers, how are report cards generated, can we have client-side validation? These are all fantastic questions, and we're going to answer all of them in spec updates or over discussions, but this can all turn into a very big discussion. But what I do want to provide all of you with is some key concepts and understandings of how the utility module is structured, so you can start framing that thinking yourself, and so you can get an insight into how we're framing our own thinking. So I mentioned all the protocol level actors that we have, and here you have another view into them. So you can think of servicers as actors that stake on a per chain, per geozone basis. You can also think of fishermen, or fisher beings, as I have here in the metaverse, as also actors that stake on a per chain, per geozone basis. And of course, we have the validators, which in typical blockchain fashion stake across the whole universe of Pocket to keep the integrity of the blockchain intact. But the interesting thing here is that servicers and fishermen have report cards. And fishermen themselves grade each other in wisdom of the crowds type fashion. Validators keep everything intact using typical BFT. And that's how they get report cards, that's how they're graded, and that's how we end up inflating and deflating the rewards, which are then distributed. So I know that probably left more questions than answers, but if you simply understand this concept of pooling, that'll kind of frame, that's a really good way to frame the thinking as you look through the specs or kind of ask further questions. So that's enough for utility, and now I kind of want to jump into my favorite module, which is the consensus module. And just to kind of give everybody, in case you're not familiar with consensus, some high-level basics, we use an algorithm called hot stuff. which was originally released in 2018, revised in 2019, and it's increasingly becoming one of the most widely adopted BFT algorithms out there. Now, it provides immediate finality. It needs two-thirds validator agreement, but the thing that makes it unique is its linear complexity, and having linear complexity and responsiveness, meaning it can move at the speed of the network, is what allows us to also keep it simple. Now, I did a lot of research looking into all of the other projects that use hot stuff out there. I looked at their tooling, I looked at their documentation, I tried to hack their chains, I copied some of their code. Maybe I didn't. I'll let you guys figure that part out. But I really did a deep dive into all of these projects, asked all the hard questions, and tried to understand what's going on. The thing that really stood out to me is note how everybody's optimizing for the highest TPS and the shortest block times. The problem with that, or rather not a problem, but a result of that, is the low validator count. So almost everyone has, in order to optimize at the L1 smart contract layer, a relatively low number of validators, which, as we all know, is a potential security vulnerability. And then I started thinking, why? Because hot stuff, in theory, wasn't designed this way. So, in theory, hot stuff was designed to support a huge number of validators. And in theory, there's all these different variations of hot stuff that you can use. And again, in theory, you should be using something called threshold signatures. And I contacted, or at least tried to contact, most of the leading cryptographers in the world on these threshold signatures, and have not been able to successfully get a response yet. But, so what's happening in practice? So in practice, rather than using different variations of hot stuff, everybody is using chained hot stuff. And in practice, like I said, literally no one is using threshold signatures. So this kind of poses some problems, this kind of poses some questions, but to me, this is actually one of the most exciting things that gets me up in the morning, because this is what makes Hot Pocket not only irresistibly hot, but also opportunistically innovative. This, everybody, is actually, we're doing a lot of crazy things, but this is going to be on fire. This is going to be hot. This is going to be so exciting. What you need to realize is the fact that we're not optimizing for the shortest block times or the highest TPS, the opportunity that this provides us with innovating and doing distributed key generation amongst tens of thousands of nodes, many of which people in this room are running, gives us the opportunity to innovate in cryptography, innovate on building one of the securest chains out there with the largest number of validators. And what I want to show you is, this is a quote from Vitalik in in an article he wrote within the past couple of months, where he says that signature aggregation is actually going to be one of the biggest problems that we're going to need to solve in the next 2 years. And Pocket has the opportunity to innovate on this front. So what you have to realize, we can have one of the largest validator networks out there, and I said this was a passion project and not on the roadmap or promised by everyone, but think of interoperability on one of the securest, highest validator count chains out there. I'm going to leave it there. All right, but now tooling. So this is Infracon. What infrastructure do we really have to build infrastructure? Again, I said that I looked at a lot of other projects. I tried to tinker with their code. And what I'll say is, dApp developers have decent tooling. We have Hardhat, we have Truffle. It's not the best, but it's also not bad. Node runners also have okay tooling, and fortunately, they can also leverage a lot of the Web 2 tooling out there, Kubernetes and Helm and Argo. So again, not the best, but it can get better. And I spent almost 6 years in the data science space, working on MLOps. And something that a lot of people maybe aren't as familiar with is that between 2012 and 2016, it was all about getting more data, writing deeper neural networks, like getting crazier algorithms. This was the real innovation in data science and MLOps. But if you look from 2016 and 2017 onwards, the real innovation in data science was infrastructure to really build and understand what's happening with your data science. And this is exactly the next step that we need to do in protocol development. So I said that I tinker with a lot of code, and the barrier to entry to protocol development is way too damn high. And I don't just say it, I can prove it. I submitted a bunch of PRs, I submitted a bunch of questions to other protocols, and I tried to really understand and get a feel for what it's like to contribute to another protocol. And one of the goals that we're trying to do is not reduce that barrier of entry so it's much, much lower here at Pocket. All right, so most of you are probably thinking, all right, that's cool. All right, Olshansky, how do you actually make things different? It's very simple. We use make. Or at least that's the tool of choice for now, and it might change. Like I said, nothing's immutable. But you clone the repo, you run make, and everything you need is right there. You can run a local net with one command. You can access the database with one of many commands. You can use make to run the unit tests or the integration tests that we have. And you can also use make to start benchmarking things. So we make things different by making things simple. It's almost as if it's all coming back and tying together, keeping things as simple as possible, but not any simpler. All right, so that's how we make things different, but how do we make things readable? How can you really understand what's going on in the protocol? And what we're doing is following a new pattern called documentation as code. So these diagrams aren't as pretty as what you might create in FigJam or in Miro, but at least they're embedded directly in your Markdown readmes. So as you're reading the documentation or as you're updating documentation, you can very easily make a very tiny, the barrier to entry to modifying it is almost non-existent. So what I'm hoping, or at least what I saw from other projects where all of the diagrams were extremely outdated and extremely hard to understand, that's not going to be the case here. All right, so that's how we make things different, that's how we make things more readable, but how do we drive it? Oh, no way. So, there's supposed to be a video on the screen right now. Let's see if we can make that happen. I was going to do a live demo, but I always know that the demo gods aren't on your side. So I figured a video would kind of make things simpler. All right. The demo gods aren't on our side today. So I'm just going to explain what would have happened in this awesome video in 10 seconds or less. So we'll share the resources with everybody here later. But basically, what happens is, with one of our make commands, you literally just run it. And if you have an empty Docker state, it'll spin up a bunch of local Docker containers. It'll bind the code from your host machine to the Docker containers. You can connect a Delve debugger. You're going to have hot reloading. And you're going to have a CLI where you can literally step through the consensus steps. You can say, I want to go to the next consensus step. I want to reset to Genesis. I want to see what's happening within every single node. This is one of those tools where there's lots of CLIs out there for node running, but I have never seen a CLI for driving consensus. This is what you will see later after the talk. It's probably going to be one of the most basic premature versions, but probably the first one. And I'm hoping that we can actually make it an industry standard moving forward. All right, so that's kind of how we drive things, but then of course, testing is also super important. So you're probably asking, well, how do we keep the blockchain safe? And how do we keep the blockchain safe from bugs and from regressions? Pocket protectors. This isn't a comedy show. This is a Pocket Network V1 deep dive. But on a serious note, testing for consensus, we have, similarly to how we're building tools to drive consensus, we're also building integration frameworks in order to very easily script end-to-end tests. So you can say, for example, when I spoke to other people developing consensus algorithms at some of those companies that I mentioned, the biggest source of issue was all these tiny little numbers and all these parameters that get updated incorrectly. Like, which round are you on? Which step are you on? Which height are you at? And you'd think this isn't really cool and exciting blockchain stuff, but that's actually the core issue when it comes to consensus development. So what we have is scripting, where you can literally say, I need to be at this height, at this step, and this should be the signature. Having the tooling and the infrastructure to create these tests easily is what's going to enable our team and the community to keep iterating on it and adding new features without asking, did I break anything? Or is this still safe to deploy to mainnet? As unexciting as it might seem, this is actually going to be the core to having us move forward. Now, one of the other things that I'm really excited about that was brought up by one of our recent engineers is this idea of DevNet. So everyone's heard of testnets and DevNets, but imagine that you can kind of create your own DevNet where you deploy 4 nodes or 10 nodes with your own code, and then some other developer could also deploy 4 nodes or 10 nodes with their own code. But then what if we start having a shared DevNet where we all deploy in our own tags without coordinating with each other? Or this could also be an opportunity to have some fun and troll each other of trying to write some hacky code, deploy it, and then seeing whether or not you're breaking the shared DevNet that we're building together. So it's an opportunity to see how safe the code that we're writing is, but it's also an opportunity to kind of troll and potentially have some fun with your colleagues. And we're also if there's if there's ever an issue or if there's a chain halt, just call 1-800-HOT-POCKET, and you know who you got to call. All right, and lastly, kind of with persistence as well, what we're doing is we're still in the early stages. We're still developing, but just last week we were writing tests, and I used Go fuzzing to kind of randomize some of our testing, and we found a bug, right? So this early on, we are finding issues, but the tooling is there. We're going to make it easy for other people to use, and that's how we're going to make things easy. Now, there's so much more that I wanted to talk, but obviously time is short. Obviously, I want to talk a lot about persistence. I want to talk about how we're using protobufs and SQL and standard serialization protocols. I want to talk about how we're going to make reads really fast and efficient. I want to talk about how you're going to be able to customize SQL schema. This is probably just going all over your heads, but we're going to have high pruning. There's so much going on. And then one of the other exciting things that I won't have time to go into today is, for example, Raintree. I spent 3 days breaking my head over this algorithm, and we have a potentially provably optimal structured gossip algorithm, which through simulations has already been proving to be exactly as we expect it to do, and I'm hoping we'll have a formal verification of that sometime in the near future too. So basically, you should start watching our repo. We're going to be releasing a lot of spec updates. We're going to start a technical blog. We're going to be sharing everything, because one of the goals here is to make it easy for everyone not to just use Pocket, but understand Pocket from a protocol level, from a developer level, contribute to Pocket, use our tooling, use our infrastructure, and just kind of build it all together. So if you have any feedback on the jokes or the technical pieces, please leave it here. Do we have any? Do we have time for questions or any questions? Say it again. So there's the official answer, and then there's kind of the answer that I want to give. So we're optimizing for everything. We want to make it. Like I said, we're keeping it as simple as possible, but not any simpler. So can we launch it, in 2 months if we really push? Probably. Do we want to? Probably not. Right? It's kind of, do we want to prioritize for having a running blockchain that nobody can understand from a documentation perspective, or do we want to optimize for a release blockchain that then anybody can kind of come in, jump into, and start implementing and start contributing to without a problem? I think a function of when we'll launch is obviously we have a team working on V0. We have the entire community supporting us on scaling V0. So that'll keep us going as long as we can. But we'll move as fast as we can with V1 too. That's all I can really say. I don't want to make promises we can't keep ourselves accountable to. Yep. Yeah, so okay, that's a really good question. And I think that you'll be able to start contributing even before we release testnet. Ideally, once we release testnet, anyone can jump in and start contributing. But even prior to that, we have a lot of commits and a lot of PRs in progress that we're currently reviewing and trying to merge in. I mean, theoretically, that make command that I showed for you to clone the repo, run it, and start running benchmarks and start running tests, like, you can do that today. Like, literally, the code is out there. You just have to be on the right branch. It's not on the mainnet branch, but that's ready right now. The testnet will be up when it's code complete, but you have to realize that what we have up right now in progress is, and Luis mentioned this in the keynote, that we've made a lot of progress on the utility and the consensus modules, but P2P and persistence are still a little bit behind, so those are actually being reviewed right now. And there's also some features such as like the relays, which we're still kind of discussing and implementing, so it might be a little premature for community members to start contributing now, but the code is up there and we're developing in public, right? And kind of, like I said, the key here is there's a lot of specification updates that are gonna come out in the near future. And one of the things that I'd say I'm personally also really passionate about and I wanna make happen is like having my sister and my parents who are not in tech being able to look at the videos that we'll have and the specs that we'll have and the diagrams that we'll have and really understand how the protocol works. Because this is one of the most overlooked problems in the industry, I think, today. Shane? So you're asking whether other projects would be able to use our V1 codebase to run application-specific blockchains? I don't know how transferable that would actually be, because what we're doing is building an application-specific code base for an application-specific blockchain, right? We're building it from the ground up, optimized for Pocket. But it's not like it's spaghetti code that's all tied together for one purpose, right? That's why we have the application-specific bus, where you can kind of drag and drop the modules that you want. So the consensus module, for example, implements Hot Pocket. If someone else wants a blazingly fast consensus algorithm, they can take that module and kind of use it themselves. But unlike the Cosmos SDK, where you just take all of the modules and you have a blockchain yourself, that's not quite how this would work. So you can take bits and pieces, or you can add your own bit and piece, but unless your utility is very, very similar to ours, which I don't know of anyone else who's doing something similar, probably not. But for example, Consensus or Raintree, like they could take our P2P module and also use Raintree for whatever they need. Yeah. Did that answer your question?
Yeah.
Cool. Anyone else? Pierre? Oh, I kind of like that, Dev Wars. That was a troll box? We'll make that happen. I also like the Dev Wars, another missed opportunity. Cool. All right, thank you, everybody.